data structures using C. Number one is data. Number two, we have structures. And number three, we have using C, right? Okay, so let's discuss these things one by one. In order to simplify structure, let's take an example of a cupboard. Okay, so you can see the cupboard in the figure. Okay, so data structures are like containers for storing and organizing data in a computer. We can see that we have organized the clothes in the cupboard, right? And like you can see number of shirts which are hanging there, and we can see number of towels or sweaters. There are certain boxes there. You can see smaller boxes also. Smaller boxes are maybe they can be used for keeping socks or ties, etc., right? And you can also see certain things like a tree kind of structure right on the right side of the cupboard, which can be maybe used for having belts or maybe some jewelries. Okay? So what cupboard does? It organizes our dresses. Okay? Wardrobe is basically a place to organize the things. Similarly, data which we use in real life can also be organized. It can also be stored. Okay? And it can be organized in a beautiful way so that we can use it in a better way. So data structures can be thought of as a different type of boxes that can hold different items. Language is something which is used to communicate. So in computers also this communication happens. The only thing is that in computers the sender is the human, but the receiver is the machine, the computer, right? Now the problem arises because we humans speaking languages like English, Hindi, whatever it is, and the computers don't understand that language. So programming language is a set of instructions used to communicate with a computer, and while communicating we create softwares which are basically used for functioning of the computers, right? Okay, so we have understood that data is required, right? And we have understood that data needs to be structured in order to be used, and we have understood that in order to use data, in order to organize the data and use it efficiently, we need to have some language also. So data structures are essential concepts in computer science and programming that serve as the foundation for effectively organizing and storing data. Understanding these principles is critical when addressing difficult computing issues and optimizing algorithms. Okay, so now let's move on to how do we categorize data structures. So what is the classification of data structures? So I'll show you a diagram and we'll try to understand the data structures using this diagram. Okay, so far we have known that a data structure is a specialized form of effectively organizing, managing and storing data. It allows for effective data access and modifications, right? In order to make the algorithms perform in a better way, in an easier way. Okay, and the purpose of data structure is organizing the data and enhancing the performance of algorithms, and also maybe the reusability of the code. If we are having a better data structure, it enables the creation of reusable codes which we can use, and this code can handle the data effectively, right? So let's come back to the diagram which we are watching on the screen right now. So data structures can be categorized into like primitive data structures and non-primitive data structures. So primitive data structures you all have learned in the earlier programming sessions, like we may have integers, float, characters, and we may have several other things as well as booleans also. I've not included everything in the kind, right? And they all occupy different spaces also. Like integer, in the old compilers they used to take 2 bytes, okay, float used to take 4 bytes, character used to take 1 byte, pointers used to take 4 bytes, and so on. Old compilers, it keeps on changing with the architecture. Now we will be moving on to non-primitive data structures, and then we can have linear and non-linear structures. Okay, under linear structures we may have stacks and queues. Non-linear structures we may have graph and trees, and so on. Okay, so we may have different kind of data structures. Okay, now having understood all the different kind of data structures like the arrays, the linked list, the stack, queue, and then we have trees and graph. Now what kind of operations can be performed on those data structures? We have data structures. What kind of operations can be performed on those data structures? All those data structures can have insertion. Insertion means we are adding new elements. All those data structures may have deletion, where we want to remove some elements. Okay, maybe we can have having a number of shirts arranged in queue, line of queue. Maybe I can remove shirt number 3. If that is being allowed, we say okay, I have performed deletion in the queue. If I can take maybe one of the sweaters, then I can say okay, I have deleted one element, one sweater from the stack of sweaters. Okay, so insertion and deletion is important. Traversal means accessing elements in a systematic order, like moving from one part to another, one by one. Okay, and then we have maybe searching, when you want to find some specific elements in the data structure we have. Like we may have students, 100 students, like maybe in our class we have 100 students who are doing BCA 4th semester, right? And then we will be like doing what? We want to find out who has scored good marks in C programming language. So we can search the data on the basis of the marks obtained. So searching is finding specific elements, right? Sorting. Now we can also sort the data structure. Suppose we have the data with us, and we can arrange the data in like maybe ascending order, descending order, and these kind of operations are called sorting. And finally, moving on, we may have the update options also, depending upon kind of how we are modifying the existing elements. We would like to update the things. Okay, so these are the basic operations which are performed on any kind of data structures.